Hi students, welcome to MI Academy. And today in this video we are going to continue the grade 10 chapter 2 of the science, motion in straight line. Until now we have studied distance, displacement, speed, and velocity. And today in this video we will study about acceleration and deceleration. If you have not still subscribed to MI Academy, then click the subscribe button, and turn on the notification bell icon, to all, so that you can watch my upcoming videos without missing. Okay students, now we'll start the next topic, acceleration. Now you all know in a car, or any vehicle, there is an accelerator pedal and a brake pedal, and you all know the function. When we want to increase the rate of the speed or the velocity of a car, we press the accelerator. And if we want to slow the vehicle down, we press on the brake. So we will see how this is related to motion. When we say acceleration, it is the rate of change of velocity, or the change of velocity in a unit time. If we put it into the equation, acceleration is equal to change of velocity divided by time. So from this, if we find the unit for acceleration, velocity is given in meters per second. And time is given in seconds, so ms minus 1, divided by second, that will become ms minus 2. We can write another equation as final velocity minus initial velocity, divided by time, so this will be the equation for acceleration. Now we will see how to calculate acceleration. The following table shows the manner in which the velocity of a body that traveled along a straight line varied with time. So here we talk about the variation of velocity, and it has to be in a straight line, and as usual it starts with the initial point 0, the time changes by 1 second, and the velocity changes gradually. As 2, 4, 6, 8, 10, 12, so you can see that the difference is by 2. So if we calculate for the first second, is 2 ms minus 1, divided by 2 seconds, at the end of 2 seconds, acceleration will be 12 minus 8, 4 divided by 2 seconds, 2 ms minus 2. Similarly, you can continue calculating for the third second. Again you can see final velocity 6, and initial velocity 4 meters per second, divided by 3 minus 2, 1 second. Then the acceleration will be 2 ms minus 2. So here you can see all the values have the same magnitude, 2 ms minus 2, and since it says in a straight line it is in the same direction, so the magnitude hasn't changed. The direction also has not changed. Since it has a magnitude and a direction, it is a vector quantity, and since both the magnitude and direction do not change, we call this as uniform acceleration. So this is another example, where there is a change in velocity. Here you can see at the beginning of the travel itself, the object is moving with a velocity of 12 meters per second. Later it is varied with time as shown in the table above. So here as you can see the object is already moving with 12 meters per second, so during the first second you can see the acceleration. Final velocity is 9 minus initial velocity 12 meters per second divided by time 1 second. If we calculate this, you will get the value as minus 3 meters per second minus 2. We get a negative value for the acceleration. Since this is a vector quantity, the negative means either opposite direction or decrease. So here it is the decrease in velocity. As you can see from 12 the velocity has decreased to 9 meters per second. This is known as deceleration of the object. So we rewrite it as deceleration equals 3 ms minus 2. Remember students, when you write deceleration you should not use the negative value. We write it as 3 ms minus 2. So when acceleration is a negative value, that is called deceleration. And I hope you understood this. In order to find the displacement of a body moving at a uniform acceleration, we should find the mean velocity of the body and multiply it by the corresponding time. It is displacement equals mean velocity into time, so you have to remember, if the object moves with uniform velocity we directly multiply the velocity by time, and calculate displacement. At the same time, if the object moves with different accelerations you cannot use this equation. So keep in mind students, if the object is traveling with uniform acceleration, we use this equation, where we calculate the displacement using mean velocity into time. When we say mean velocity, that is the average velocity. We'll do some questions, so that you can get a clear idea. So as an example, if we look at this question, a body that starts from rest is subjected to a uniform acceleration for 6 seconds, after which it acquires a velocity of 12 ms-1. What is the displacement of the body? So here you know the acceleration is uniform, the time is 6 seconds, and the velocities are initial 0 and final 12 meters per second. So first we calculate the mean velocity. It is initial velocity plus final velocity divided by 2, that is 0 plus 12 divided by 2, that is equal to 6 meters per second, so that is the mean velocity of the object when it is traveling with uniform acceleration. So then if we calculate the displacement will be equal to mean velocity into time. So here you can see we already have the value for mean velocity, 6 meters per second. And the time is 6 seconds, so 6 into 6 is 36 meters, so that is the displacement of this object that moved with uniform acceleration. Another example, a body starting from rest accelerates for 4 seconds, and acquires a velocity of 12 meters per second, thereafter it moves at a constant velocity of 12 meters per second. So here it is constant velocity for 4 seconds, and ultimately comes to rest after 2 seconds, so as you can see the object has 3 types of movement included here. Initially it is accelerating for 4 seconds, then moving with constant velocity, and then decelerating. So the first question is calculate the acceleration during the first 4 seconds, so as you all know acceleration is equal to change of velocity divided by time. So here it started from rest and accelerated for 4 seconds, and finally 12 meters per second, you all know it is final minus initial, so final is 12 meters per second minus initial 0. Divided by time is 4 seconds, that will be equal to 12 meters per second, divided by 4 seconds, the acceleration will be 3 ms-2. Then next, find the deceleration during the last 2 seconds, so here you can see from 12 meters per second, again the object came to rest, but when you write the equation you have to rewrite it as acceleration equal final velocity minus initial velocity, divided by time. So here we can see final velocity is 0, minus initial velocity 12 meters per second, divided by 2 seconds, that will be minus 12 divided by 2, the value will be minus 6 ms-2. So here you can see the acceleration gets a negative value, so that means the object is decelerating. So what do we do now? We write it as deceleration equals 6 ms-2. So now you have a good understanding as how acceleration and deceleration are calculated. Now we will go to the next question. What is the displacement of the body during the 10 seconds? Since this has no uniform acceleration until the last, we have to divide them into portions and find the displacement. So first let's find the displacement during the first 4 seconds. If you remember, first 4 seconds the body accelerated starting from rest and it reached a velocity of 12 meters per second. So here it is acceleration. To calculate the displacement, here we have to use the mean velocity, so first we'll find the mean velocity, so final velocity plus initial velocity, divided by 2. So that will be equal to 0 plus 12 divided by 2, that is going to be 6 meters per second, and if we calculate the displacement will be mean velocity into time. 6 meters per second into time 4 seconds, so 24 meters. Then what is the displacement of the body when it traveled with uniform velocity? Here we directly multiply velocity by time to calculate displacement. So here displacement is equal to velocity into time, so as you all know after it reached 12 meters per second, it traveled with uniform velocity, so 12 meters per second into 4 seconds. That is equal to 48 meters. Next, the displacement of the body during deceleration, as you all remember the body was moving at a velocity of 12 meters per second came to rest, here again the velocity is decelerating. So here we need mean velocity, then I will take the initial velocity as 12 meters per second, and then final velocity 0, divided by 2, so we get the value as 12 meters per second divided by 2. Again you get the average velocity 6 meters per second, and here displacement is mean velocity into time, so that will be 6 meters per second into time 2 seconds, so the value will be 12 meters. So the body has moved or displaced by 12 meters within the last 2 seconds with deceleration. So now what is the displacement of the body during the 10 seconds? So here the total displacement of the body, you all can see children, initially the object is accelerated, then it displaced by 24 meters, then again with constant velocity it was 48 meters. And finally with deceleration it is 12 meters, so for the total displacement we will have to add up all the values, then finally, 84 meter. Okay, I hope you all have understood this calculation. So students, up to now we have discussed distance, displacement, speed, velocity, and acceleration. I hope you all have understood how to calculate them. The next part of the lesson we will put these data in graph form, so we will see how to draw different types of graphs related to motion of objects in our next video. So please subscribe to MI Academy, and turn on the notification bell icon, to all, so that you can watch my upcoming videos without missing. Also please, like my videos, and add up your questions and doubts in the comments.